Okay, in this gem of a video, you're going to learn a different new type of factoring. You'll have this sheet to go along with it. And it's called perfect squares. Now, if you don't know what a perfect square is, it's a number that you can write as a factor times itself. So you got 1, 1 times 1. 1's a perfect square. 4, 2 times 2. So the number 4 is a perfect square. 9, 3 times 3. The number 3 is the number 9 is a perfect square. 16, 4 times 4. So 16 is a perfect square. 25, 5 times 5, and 6 times 6. All these are perfect squares. These are not perfect squares. It's the product that's the perfect square. X to the second is also a perfect square because you can write that as a factor times itself. Actually, a variable to any exponent, as long as it's even, can be written as is a perfect square. Because if that was x to the fourth, that could be x second times x second. If it was x to the sixth, that would be x third times x to the third. You know, an odd wouldn't be. Now, to warm up here, what I want you to do is multiply this out. And you're going to see what happens here. These are what are known as conjugates. I want to see that word written down. C-O-N-J-U-G-A-T-E-S. Conjugates. Okay, now the reason why they're known as conjugates because they have the same thing in the parentheses except you have a plus and a minus. Okay, that's what makes them conjugates. So what I do is multiply 5x by 5x. 5x by negative 2, and then 2 by 5x, and 2 by negative 2. And something's going to happen here. 25x to the second, negative 10x, positive 10x. Now, those are opposites of the same thing, so those are going to cancel. Okay? And that's negative 4. Okay? Because if I add those, they just add to 0. They are like terms because they're both x's. Okay? So really, I just have 25x to the second power minus 4. And that always happens when you're multiplying conjugates. The middle two will cancel out, and you'll have just the x squared term and the constant. Okay, so let's use, with conjugates, I know that this is a waste of time. So really, I can just take x times x, which would go x second, and 3 times negative 3, which would be negative 9, so minus 9. And what these are known as, the products are known as, are called difference of perfect squares. 25x to the second minus 4 is a difference of perfect squares. Because what we're going to be doing is taking the product and getting it back to the original two factors. Now, some of you might have an idea how to do that. It's really not hard. Now, what I like to call difference of perfect squares, I like to abbreviate it because I don't want to write that every time. I just write DOPS, difference of perfect squares. Okay, and then the next one, same idea on this product here. Again, you got their conjugates. Same contents, just one's positive, one's negative. So let's take 10x. So we really just need to find those two products there. That'd be 100x to the second, and that's going to be negative 1, so minus 1. Okay? And again, this represents a difference of perfect squares. Now, factoring difference of perfect squares is easy. Okay? And that's all you're doing today. You know you want to try to make conjugates out of this. Okay? One's positive, one's negative. Well, do we have a minus sign first? That has to be a negative, that number right there. It has to be, and it is. If it's positive, this is not doable. And 16, we know, is 4 times 4. Okay? And then x to the second power, we know, is x times x. So, yeah, I can write x, and then 4 and 4. Okay? That's the factored version. Okay, now here's what you're going to do on this one. I didn't write the instructions very coherently here. Okay, so this is what I want done. I want you to see if you can make this a different into two conjugates. I want you to see if that's a difference of perfect squares. So here's what you can write. DOPS question mark, and then make two parentheses, one with a plus, one with a minus. Well, the first thing you check for is the sign. It's minus, so that's a negative, so we keep looking. If it's plus, then right away it's not doable. Now 16 is on my list. That's 4 times 4. But the number 2 is not a perfect square. Now, I know not from over here. You can't write 2 as anything times itself. Okay, 2 is not equal to anything times itself. So since I couldn't split 2 into the same factor, cross it out. Then you're done. Okay, next one. DOPS question mark. Well, in this one, again, we have our minus sign. That always has to be there. That can't be a plus. Take 25 is 5 times 5. X to the second, yeah, that's x times x. So yeah, I can do this. So I put x, 5, 5. So basically, first you check your sign, and then you see if you can write the two things as something times itself. Okay? So that's what I want to see. Okay, the next one. DOPS question mark. The right sign's there. 81, that's 9 times 9. 4 is 2 times 2. And x to the second is x times x, okay? So you bet that's 2x, 2x, and then 9, 9. Okay, next one. DOPS question mark. We got the wrong sign, so it can't be done, okay? Plus, minus, but you can't do it, okay? If it's a plus, we don't do it. Okay, DOPS. Remember, when you take when you're really seeing if you can write it as a factor, as a factorization of two conjugates. Okay, we have the right sign. Okay, and 16 is 4 times 4. But how about 8? Nope, 8's not a perfect square. Okay, so can't be done. Cross it out. Okay, DOPS. Plus, minus. Got the right sign. 1 would be 1 times 1. 9 would be 3 times 3. And x to the second power would be x times x. So I just connected x onto each 3. Okay, so that's 3x, 3x, and then 1, 1. So DOPS. Got the wrong sign, can't do it. I don't care that that's 6 times 6 and that's x times x. If it's got a plus, it can't be done. Okay, now we got the right sign. Okay. Now don't write 5, 5. 5 times 5 is not 10. 10 is not a perfect square. Don't do it. Okay, you can abort mission here. I want you to do something here on one of these. I want you to switch that to just an x, please. 4x minus 81. Okay, so DOPS. Okay, we got the right sign. 16 is 4 by 4. 5, no, can't do it. Remember that we want to see if that is a difference of perfect squares. Only if it is can you write the two, fill out the conjugate parentheses. Okay, so you got the right sign for a positive times a negative. That's good. 81, 9 times 9. And x to the second can be x times x. Okay, so x plus 9 minus 9, done. Okay, these next two are kind of tricky. They're easy to get fooled on. You got the wrong sign for a positive times a negative. That can't be, so you get rid of it. You just move on. Now, I took the second power away from that. I want you to pretend that that second power was not there. Okay. Well, you got the right sign. And 81 would be 9 times 9. And 4 would be 2 times 2. But if our x is not to the second power, we can't do that. Okay, x has to have a power and it needs to be even. Because right now that's a first power. That's odd. You can't split an odd power up evenly. Okay. Okay. You got minus. Okay, that's there. 1 times 1, 49, 7 by 7. Then x to the second is xx. Okay, so this can be done. Everything works. Had the right sign, have the right things. Fill it out. Okay, sign is right. 17's not, though. Now again, just because you have the right numbers doesn't mean, that's the wrong sign. Can't do it. Have to have the right sign. That right sign is a minus or a negative, however you want to go about it. And then you need the right, perfect squares. It's called difference of perfect squares for a reason. Difference of perfect squares. You can't have a plus. You got the wrong sign right away, so you know you're not doing it. Okay? All right, now you need to do these ones here. When I look at this, I see 3 that will be differences of perfect squares. The rest of them you will cross out.